Okay. I know, that was my fault. Sorry. Which one do you want to ask about? We have a vote for 6 and 7. Is anybody else voting for 6 and 7?
Yeah.
Okay, let's take a look at this one. 6 and 7. Says the graph of y equals the square root of 3x minus x squared is given. Use transformations to create the function. Use transformations to create a function whose graph is as shown. Okay, excellent. That's pretty neat. So you're taking, it's giving you the first function, and you're trying to transform it into that right there. So what's the first thing you notice? What's one thing that happens between the base function and 6? It's shifted to the right, it looks like. Yeah, it looks like it's shifted to the right how much? Shifted to the right. So if this is, let's just say that this is f of x. So if you shift it 2 to the right, that means you're going to do f of x what? Minus 2. So now what do we have? Therefore we'd have our new function is going to be y is equal to the square root of 3 times what? 2 minus x minus 2 squared. You have to subtract 2 from all the x's. You have to subtract 2 from all the x's. Now though, there's what else is there's another problem.
It's compressed. Oh, no.
Yeah, it is compressed, but hold on. No, is it compressed?
It's not compressed.
It's not compressed because from 0 to 3, same thing as 2 to 5. What is it? It is stretched. Which way?
Vertically.
By what factor?
2.
2. So we know it's stretched vertically by a factor of 2. So what do you have to do to the function? It'd be at 2 times f of x. So what do we think the function is?
2 root 6
2.
x minus 2 minus.
Yeah, you don't have to multiply it out. Just do this. Keep it like this. Like that. That's fine.
Alright.
How could you go about checking this?
Putting that value.
You could graph it on your calculator. Do you want to graph it on your calculator? You want to test? So there's our that's our window, and we graph this. Now, is there actually a gap right there? Like, does the graph stop right there? It just is so steep it can't graph it. It's steep enough that the calculator can't handle graphing it that steep. So if you zoomed in right here, would you still see a gap?
Nope.
No, if you zoomed in, would you see the line? Yeah, you absolutely would. So we end up with this right here. So did it work? Yeah, it did work. Okay, so what about the second one though? The second one, right here. Did the overall shape change? No, we didn't constrict it at all. So let's just write this out. We know that, did it move up or down, or both? Yeah, what's the main transformation that happened? Over the? Reflect over the y-axis, right? Yep, and the. So we know it reflect over x and y-axis. So to do the reflection, what would you have to say? You'd have to say y is equal to negative what? Negative x. Negative f of negative, because you want to flip it over both. If we flipped it over both, this would be the original. You'd flip it like this and then flip it down. But it also did what? What else did it do? Did it go down or up? Depends on what order you do it in, right? So if we flip it first, where is it now? It's now sitting where? It's now sitting right there. Actually, it's now sitting where? From 0 to 3. It's now sitting right there. So now what do you need to do? Are we moving it left or right? Move it to the left. So we need to go left how much? Left 1. So what's that going to be now? So now we have y is equal to negative f of negative x what? Plus 1. Correct? Let's finish it down here. But now, what happened to it? Now the whole thing gets moved how much? How much where? So we think it's going to be y is equal to what? Negative f of negative x plus 1 minus 1. So what was our original function? The square root of, so what did f of x equal? The square root of what? 3x minus what? So we think it's going to turn into, our new one, g of x, is going to be negative the square root of 3 times negative x plus 1, right? Minus negative x plus 1 squared, all minus what? 1.
So what if you, instead of making
Ah.
it reflect over the y, you just shifted it?
So is there going to be multiple ways to do this? Yeah. You
So
could
also
shift it
that-
over. Yep. Let's try it this. Let's see if it works. And also, depending on the order you do it in, can you come up with different formulas? Yeah, you can. Yeah, you can. So a great way to check this would be to graph it. Let's take a look. It does match what we want. The problem, though, is... Well, it's seemingly not the right equation. It seems like, does it go down far enough? I mean, let's see. Is the curvature changed? So what's going on to negative 2.5? How can we verify that it goes down to negative 2.5? Minimum, right? Second, you could do table, but let's just do second calc, and then do minimum, which is 3. What's the left bound here? Negative, there's the cursor. There's our left bound over here. Enter, and what does it ask for next? Right bound, enter, and then in the center, enter. Ah, does this match exactly what we want?
Yeah.
It does match exactly what we want, but what's the problem?
You reflect it over the y-axis, and
Yeah, if you multiply out, you should get the same function. Yes, absolutely.
The reflection is the last one.
Do reflecting last. And can you tuck in your shirt? And do up your button so you look like a big boy? That'd be good. Okay. Other questions from the homework? Anything else you want to talk about?
Talk about the problem that we can finish it.
Nope. Oh, the one we didn't finish. Oh, in the notes from yesterday.
Yeah.
So from yesterday, you're talking about... Ah, man. I did the wrong one. Hold on. Cut this. We're in B block, right? We're going to delete that, and we're going to paste that. Good. So yesterday, we had the ended with... it was just completing the square question, right? This one?
Yeah.
So you want to finish this one? Do you guys not like fractions? Do they make you sad? Oh, come on. Fractions are numbers too. Don't discriminate. So what should you do next? What's next step? Someone use a hand. Hand. I'll call on you. Yes. Yeah. This is more for just making it a little easier just to see what you're doing. Here you go. Now what do we add to both sides?
Plus 4.
We add 4 because it's 2 squared, half of 4 squared. Add 4. So what does the right side become? That's y minus what over 2? 8. What's it going to be? 3 over 2. And it's x plus 2 what? Squared. So then you have y over 2 is equal to x plus 2 squared minus, multiply by 2. X plus 2 squared minus, all done. Bingo. Does that make you happy or sad seeing that? What? Makes you happy? Okay. So it says, how is the graph of y equals the absolute value of x related to the graph of f? So if you're doing the absolute value of x is the input, right? So if you take the absolute, what's the definition of the absolute value of x? Distance from 0, right? And the distance is always what? Numerically, that means this. The absolute value of x is equal to x if x is greater than 0. It's equal to 0 if x is equal to 0. And it's equal to negative x if x is less than 0. That's the piecewise definition of absolute value, right? So if you're plugging in the absolute value of x, the absolute value of x is always what? It's always positive, right? So let's just pick a function here. Let's pick a function. Let's do y is equal to x cubed. What does that look like? A little S-curve, right? Correct? It's pretty steep. It's steeper than x cubed. So if that's f of x, so if f of x is equal to x cubed, we'll write it like that. I want to graph f of, oh, I need a bracket, not a, f of the absolute value of x is going to be equal to the absolute value of x to the what power? To the cube, right? The absolute value of x is always what? Positive. A positive number cubed is always positive. So what is this graph going to look like? Part of it's going to be the same and part of it's different. What part is going to be exactly the same?
The right side.
The right side, to the right of the origin. So this is going to be the same. I'll do it over here. You know that it's going to, so that's going to be different, but you know that this is going to be the same, right? So what's going to happen to the left-hand side? It's going to be the same as what happens on the right. In this case, it's symmetrical, so yes, it is a flip of what's already there. So what is the right side going to look like? It's going to look like that. It's going to be steeper than x squared. Is it going to be this? Is that graph going to be symmetric right there?
Yeah.
Absolutely. The only reason it's symmetric, though, is because this graph, what kind of function is that? Is it an even function? It's an odd function. So in this case, you get a lot of symmetry because it's an odd function. It flips it up. Is that always the case? It's not always the case because are all functions odd? No. Let's do another one. Let's try, for example, let's try doing this one. Y is equal to, let's say, x minus 1, x minus 5. What type of function is that? Quadratic. What are the zeros?
1, 0,
1 and 1, 0 and
5, 0.
5, 0. And it's a quadratic facing up, right? So does it approximately look like this? Does it approximately look like that? Absolutely, it approximately looks like that. My question to you is, if this is where it gets a little trickier, everybody. If that's f of x, what would the sketch of f of the absolute value of x look like? By yourself, try that. See if you can sketch it. Sketch that for me. So this graph right here, what does this graph look like right here? The graph is this whole thing right here. It's the W shape. It annihilates what's to the left of it, so it automatically makes it a what type of function? When you plug an absolute value around it, it automatically makes it a even function. Let's test this and see what happens if you don't believe me. It sure did. So we have those functions right there. And did it work? Absolutely. Yes, Hanley.
I thought absolute value x shouldn't be, x shouldn't be 0, right? I mean, x shouldn't be negative, right?
X isn't negative in this case. What the point is when you're taking it, like for example, when you're plugging in the value this, -3 or whatever, right? When you plug in -3, f of -3, like that, is the same thing as f of 3. You're not actually plugging in anything negative. You're plugging in the absolute value of -3, which is 3. So it has to be even. It must be even.
It can be negative numbers, but it has to be exactly the same as the positive.
Exactly. So let's go back to that question, which asks, how is the graph of f of the absolute value of x related to the graph of f? Well, everything to the right of the y-axis will be the same. To the right of the y-axis will stay the same. And what else? To the left, what happens to it? To the left, deleted and replaced with what?
Reflection.
Replaced with reflection, yep. Sketch the graph of sine of the absolute value of x. Ah, it's close. Sine of the absolute value of x, everybody. What does y equals sine x look like? What does it go through? It goes through the origin, right? Does it go up or down from the origin? It goes like this, right? So what happens? You delete what? You delete that side, and what does it become? Whee! Like that. Cool, huh?
Yep.
So this right here would be y equals sine of. Is that a cool? That's a cool thing. It's pretty neat. I like it. And then what's the third function as? Sketch the graph of y equals the square root of the absolute value of x. Y equals the square root of x. What does that look like? It's only defined to the right. So if you do this, what changes? What changes?
Domain. I think it changes the domain. Right?
What?
On the left side too.
There is no left side, everybody. Can you plug in negative numbers into this? Ah, but for over here, can you now plug in negative numbers?
Yeah.
Yeah, what is that going to look like? Whee! It reflects it over. So what's the domain here of this function? What's the domain? All real numbers, right? What's the domain right here? Greater than equal to 0, right? Pretty cool?
So
So
Okay.
the length of the y-axis will be same as the...
To the right, yes, exactly. That's a good call. Functions. Combination of functions strictly means adding or subtracting, multiplying or dividing two functions. That's it. The one thing we're really going to focus on is the domain of the new function. So let's read this. Let f and g be functions with domains a and b. Then the functions f plus g, f minus g, f of g, and f divided by g are defined as follows. If you have two functions, f plus g of x, which is f of x plus g of x, the new domain, what does that upside down u mean? Anybody know? Intersection. Do you guys have a pretty good idea? Have you done it before, finding the domain of a function? Could you find the domain of a second function? The domain of f plus g is going to be the intersection of those two sets. So for example, let's say the domain of a function f, let's say f of x had a domain like this. X was less than 3 and greater than 0. And g of x, the domain was x is less than 5 but greater than 1. Let's do that instead. Where do they intersect? Where do these two sets intersect? Greater than or equal to what? And less than or equal to? 3. That would be the new domain, exactly. It's the intersection. Now, similarly, what about subtraction? Does anything really change with subtraction in terms of domain? No. In terms of subtraction, the domain is still the intersection. That should make sense because if you're combining two functions, you're now plugging in those numbers into both functions. So whatever numbers you use as your inputs have to be able to be plugged into the other one, both of them. So if you have the domain of one function here and the domain of another function here, and you combine the functions, what do you have to look at? You look at the intersection of their domains. For example, on this set right here, can you plug in 5 into this function? No. Can you plug in 0 into this function? No. You need numbers that can be plugged into both, so you look at the intersection. Now, for multiplication, same exact thing. Division is the same exact thing, except there's one thing you can't use. You can't, can g of x, if you just had a function, is g of x allowed to equal 0 if you had g of x all alone? Can functions equal 0? Yes, they can. But if they're denominators, can denominators equal 0? No. So the only thing you have to watch out for combination of functions for the new domain is if the denominator is going to equal, and you have to take that away. That's it. That's all you have to watch out for. Let's practice these a little bit. Here you go. If f of x is the square root of x and g of x is the square root of 4 minus x squared, find the domain of f plus g, f minus g, f times g, and f divided by g. Find those 4 domains for me. No. So the only thing you have to watch out for, the only difference is right there. The only difference is right there.
I have a question.
Yes.
What is that?
What does what mean?
So there's a symbol on top.
On top where? Are huge fans of shorthand because there's only a few words they use this over and over and over again. What does this mean? This means the brackets mean the set, and that means contained in. A member of. What does that mean right there? Intersection. What does the bar mean? Such that. So can you read that? The domain is the set of numbers x contained in the intersection of the sets a and b, such that g of x does not equal 0. That's very common math.
You mean such that means just and?
The words such that. And such that.
Such that means just and.
Yes, you can, technically speaking, you could say and, but it's clear if you say such that. Yes. Another way to say that, I'll write that down. And. Sure. And g of x does not equal 0. Yep. So like my favorite colors, all the colors such that none of them are purple. It's another way to say it, okay? So we're pretty good. So here's g of x, the blue. Here's f of x, the yellow. If you add two functions together, are you changing their x coordinates?
No.
No, you're adding together the y coordinates, right? So you see this right here, this line, all these y values. You take all these y values and add them to the yellow values. All of these, what are the y coordinates here? All of these y coordinates are positive. All of these y coordinates are positive. So if you add them together, you're going to end up with these right here. So if you actually made a table of values, could you add together the y coordinates pretty easily? Yeah. So if you take this blue function right here and add it to this yellow function, what do you end up with? The red function right there, the purple or red, right? Exactly. Well, you kind of stretch it. You're adding more and more, right? It stretched it a little bit because are you adding a constant amount to this whole thing?
No.
No, you're adding more and more and more and more to the function. So what's it doing? It's stretching it vertically. Yeah. So visually, that's what it looks like. That's what it looks like when you add them together.
What is FA?
For specific values. So from here to here, the distance underneath the function is the function evaluated at A. The function evaluated at A, the function evaluated at A. So right from here to here, this right there, that represents f of A. Yep, sorry. This represents g of A, and what does this represent? F of A plus g of A. You add them together. So you add them together. Are we good with that? So this distance right here, do you see this f of A? This distance from here to here is f of A. Right? Does there have to be a second point? A is just any x value. Any x value. Look, what's f of A plus g of A minus g of A? F of A, the distance between the two, yeah. Okay, let's move on a little bit. Okay. Let's talk about domain here. So this is the same idea here. Here's a function. That's a semicircle. You've seen functions like that. That's the square root of 4 minus x squared. And we also have this function, the square root of x. If you add them together, what does it look like? It goes like this. Why is the function, why does it start there? Why doesn't it start over here?
It needs to be with the domain.
It has to be the domain, right? What's the domain of the yellow function here? All the positive numbers, right? You could take this. Let me clip this out. What's the yellow domain? What's the domain of the yellow function right here? Yeah, greater than or equal to 0, right? What's the domain of the blue here? Oh, it's the same functions, right? The domain of the blue is x less than or equal to 2, less than or equal to, or greater than or equal to negative 2. So if you add them together, the new function is right here. So it goes from that point all the way to that point. Well, you know that it has to stop at 2 and it has to stop at 0. So what's the domain of the new function? Between what?
Between 0 and
2. Can it contain 0 and 2? Sure. Because it's not division. We're not dividing. If you made a table of values, is that a really easy way to graph the composition of functions? Sure. If you have the actual functions, do you have other ways to graph them? Absolutely. I mean, if I gave you a table for f and a table for g, and I said, what's f of f plus g? You add together all the y coordinates. The inputs are always the same. Pretty straightforward. We like that?
So only add up the y
Mm-hmm.
values and domain change.
Yeah, then you change the domain you limit the domain appropriately. Yep. Okay, let's keep on moving. We need to do the next C, which is composition of functions. How many people have seen the word composition of functions before, the phrase composition? Simply put, composition of functions is taking one function and putting it inside another. That's all it means. You take one function and put it inside another. Have you done that many times before? You have. When you solve for the intersection of lines, what's your favorite method for solving for the intersection of two lines?
assuming that it's 0.
Set them equal to each other.
No, not setting them equal. What method? Finding the intersection of lines. Yeah, what's that method called? Putting a begins with an S? Substitution. What is substitution essentially? Composition. You are taking a function and what are you doing with it? Plugging it into another. That's all you're doing. So given two functions, f and g, the composite function, do you see f? You see this open dot right here? See the open dot? Does the open dot mean multiplication? No! What does the open dot mean? Substitution means composition. Means composition. Called the composition of f and g is defined by this. I'm going to write this down for you. Here's the notation you need to remember. Composition of functions. So our composition of functions, as you see right here, you can write it three ways. You can write it three different ways. F composed of G is the same thing as f composed of g of x, which is the same thing as f composed of g of x. So in this case, what function are you plugging into which function?
G of x is plugging.
You're plugging g into f. Let's look at that one more time. You are plugging g into f. So which function is being run first? Which function is being run first? G, and then you take the output and you plug it into f. The function on the inside is first. The function on the outside is last. So again, you take x and you plug it into the function machine g. You get out an output, which is g of x. And where do you plug g of x? Into f. Into f. This right here represents all the possible input values. G takes it to g of x. And then f takes it to f of g of x. Just remember this. The function on the inside, you run it first. You run it first. Okay, I will write the homework into your notes. You can check your notes and get the homework.